Hello guys, welcome back, PK here. So in this video, I'm collaborating with prime Newtons for this interesting Diophantine equation, so stay tuned. Hello guys, welcome back, PK here. So in this video, we're going to be solving this interesting algebra question from Junior Math Olympiad. The question is solve x and y. They're both integers. Then we have square root of x minus square root of the y plus square root of x plus square root of the y is equal to square root of xy. So for this question, we can easily find this one trivial solution when both x and y are equal to 0, right? So number one, trivial solution is both x and y are equal to 0. But then again, we need to make sure that if we have the other solution, right, we can work this out by assuming that both x and y are greater than 0, first of all. Then we can square the left and the right hand side of your equation, right? If you go ahead and do that, then we will have x minus square root of the y, and then plus x plus square root of the y, and then plus 2 times square root of, now you're multiplying those two, right? X minus square root of the y times x plus square root of the y. That is just going to be equal to xy, right? So in this case, on the left-hand side, we can cancel those square root of the y, right? So that's why the left-hand side is eventually x plus x, that is 2x. Then we have plus 2 times parenthesis. Inside has to be x squared minus just the y. That is still equal to xy. And if you subtract 2x from the left and right-hand side, then we will have 2 times square root of x squared minus y. That is equal to xy, now minus 2x. This one, we can pull this x out and make a parenthesis, then we have y minus 2. Now you can take a look at this inside of your square root on the left-hand side of your equation. We have x squared minus y, right? So x squared minus y, first of all, that should be greater than or equal to 0. But then again, we already assumed that your x to be greater than 0 and also y to be greater than 0. But then again, this right-hand side, x times y minus 2, this should be then greater than or equal to 0 too, right? Given how x is strictly greater than 0, that means this y minus 2. This has to be then greater than or equal to 0. That says your y is greater than or equal to 2. Okay, that is the one condition about the y, right? Okay, now what I'm going to do is I will square the left and the right-hand side of this equation, right? So once again, your left-hand side was 2 times square root of x squared minus y. That was equal to y minus 2x. So we are squaring the left and the right-hand side. Then on the left-hand side is going to be 4 times x squared minus y. And then your right-hand side is going to be x squared y squared and negative 4x squared y plus 4x squared. If you distribute your left-hand side, that is going to be then 4x squared minus 4y. That is why we can cancel those 4x squared on the left and right-hand side, right? Then if you move this negative 4y to the right-hand side, then eventually we'll be working on x squared y squared minus 4x squared y plus 4y. That is equal to 0. All of these three terms have y as the common factor. So let me factor that out. Then we will have now y parenthesis x squared y minus 4 x squared plus 4. That is equal to 0. Okay, now we can focus on these two terms inside of your parenthesis because we already assumed that your y was greater than 0, strictly greater than 0, right? Okay, then if you focus on those two terms inside of your parenthesis, that two terms, we can factor this x squared out and make another parenthesis, then we have y minus 4, and then plus 4 after. Since, once again, we already assumed that your y is greater than 0, right? Strictly greater than 0, that means this parenthesis should be equal to 0, which means this whole expression should be equal to 0 then. That also means then your x squared should be equal to negative 4 over y minus 4. Okay, So from this, since we also assume that your x to be strictly greater than 0, right? That means this denominator, y minus 4. Y minus 4, first of all, should be a negative number. That means your y has to be strictly less than positive 4. This is your second condition about the y. But then again, we already have the first condition about the y. That is y is greater than equal to 2. So that's why the range of the y should be between 2 inclusive and 4 exclusive. Since we're looking for integer values for both x and y, that means the possible value for the y is 2 and 3. We can check whether if only one of these two numbers is working or all of these two numbers are working, right? So let's check with y is equal to 2 first. Okay, let's check when your y is equal to positive 2. That means we can plug this y value to this y there. That means your x squared is equal to negative 4 over 2 minus 4, that is negative 2. That is equal to positive 2. That gives x to be plus minus square root of 2. But then again, this is not an integer. So that's why this is not an answer. But then again, we can move on to when y is equal to 3. When your y is equal to 3, then your x squared is equal to negative 4 over, now 3 minus 4, that is negative 1. That is positive 4. So that's why your x is plus minus 2. Okay, based on our calculation for case number 2, when y is equal to 3, your x turns out to be plus minus 2. But then again, we assume that your x to be strictly greater than 0. That means we only need to take your positive sign. So that's why, other than when x and y are both equal to 0, the second set of the solution is x is equal to positive 2, and then y is equal to 3. So final answer for this question is x and y is now first 0 and 0, both. And then the second one is x is equal to positive 2, and y is equal to 3. That is your final solution for this question. Okay, so pretty interesting algebra question. So I'll be back with more videos, more questions like this sometime soon.